Hello. In this video, we'll talk about dependency injection in the Spring framework. Dependency injection is a very important technique in software development. Spring framework supports dependency injection, which I think is a big part of the reason why Spring became so popular. So why this technique is so useful? Let's look at an example. Suppose we have a controller, and the controller gets a list of guestbook entries from data storage, then pass it on to a view to display. In production, the data is stored in a database, but during unit testing, we want to get the data from an array because accessing the database is too time-consuming for quick-fire unit testing. Obviously, we don't want to change the code and recompile it every time we need to do some testing. So the natural thing to do is to create an interface that defines the operation. Let's call it getEntries. And then we can create two implementations of this interface. One gets the entries from database, and the other one gets the entries from an array. And now the controller would look like this. Notice that this controller now only depends on the interface. The idea is that we can simply use the mock service, this one for testing, and then the real database service during production without having to change the controller code because the controller only depends on the interface rather than a specific implementation of the interface. Now, unfortunately, although this idea is the right idea, it doesn't quite work like this. And the reason is simple. We have to instantiate this service. Otherwise, when we call service.getEntries, we will get a null pointer exception. So how do we instantiate this service? Well, we can't just say new guestbook service. Now, this won't work because a service doesn't have any actual implementation. This one doesn't really implement getEntries. So we can't create an object out of an interface. Java will give us a compilation error right here. Instead, we'll have to say new either guestbook DB service here. We can do either this or we can say guestbook mock service. Now, notice that essentially this takes us back to square one. So despite our design to program to interface, we still end up having to specify in the code which implementation we use. And it causes the same problem as before. Anytime we need to do testing, we need to change this to mock service. And anytime we need to push the code to production, we need to change this to DB service. Changing this one line may not seem like a big deal, but remember that in a big application, we may have many controllers and many services, and there are also other places in the application that may have the same problem. Well, this is where dependency injection comes to the rescue. The idea is that instead of application code instantiating objects, a framework like Spring is responsible for instantiating those objects, then pass them to the application code that needs them. In other words, the framework injects the objects to the code that depends on those objects, hence the name dependency injection. Occasionally, you may see the term inversion of control, which is basically just a fancier way to say dependency injection. It's an inversion of control in the sense that application code used to control the creation of objects, but now the control is inverted to the framework. Here are a few terms that are commonly used in dependency injection in Spring. Beans refer to the objects that are created and managed by the framework. Only beans are eligible for the dependency injection. The bean container is a part of the framework that manages the beans and performs dependency injection. And wiring means injecting a bean into another bean. These terms are illustrated in this diagram. In this example, when an application starts, the framework will create 3 beans: guestbook DB service, guestbook mock service, and guestbook controller. And depending on the configuration, it will wire either the mock service bean to the controller bean or the DB service bean to the controller bean. Another thing I want to show here is that the application may have other objects that are not beans. Those objects are not managed by the framework and they cannot participate in dependency injection. So what's the difference between a bean and a non-bean object, which I would call a regular object? Well, regular objects are the objects we create in code using the new operator. For example, if we say somewhere in the code like list of string as is new array, list of string, something like that, then S would be a regular object. It's created using the new operator, meaning that it's created directly by the Java virtual machine. It's not created through the Spring framework. And as shown in this picture, it will be one of these objects, so it cannot participate in dependency injection. So what about beans then? Well, it's easy to recognize beans in Spring because they are annotated with some special annotations. We saw one of those annotations before, controller, and here. And this basically means that this class will be used by the Spring framework to create a controller bean. Note that we don't need to create a bean object ourselves. In other words, you'll never see inside the code that says new index controller or something like that. You'll never see code like this because the framework will create an index controller object out of this class. We never need to create it directly. If we do create it directly, then it becomes a regular object. So we have to let Spring to create it. So the way it works is that when an application starts, the Spring framework will locate all these classes that are annotated with this type of special annotations and then create beans or objects out of those classes. And because the framework creates those objects, it can manage these objects and it can pass one object to another and do the injection thing. So what are those special annotations used to annotate beans other than controller? Well, In addition to controller, there are also service, repository, component, and bin. To understand those annotations, it helps to know a little bit of common application architecture. Typically, a MVC web application has a number of layers. At the bottom is the data storage layer, which is usually a database. And then is the data access layer. This layer often uses the so-called repository design pattern. We'll talk about the repository pattern when we get to the database access part. But basically, this layer translates the data from its format used for storage, like rows and columns in relational database tables, to collections of objects used by our application. And then next layer is the service layer. This is where the so-called business logic is implemented. For example, when we place an order on Amazon, we just click a button, but there's a lot happening on Amazon's site when that button is clicked, like charging our credit card, saving the order, notifying warehouse about the order, and so on. Those logic is implemented in the service layer. And then it's the controllers, which handle requests, and the views, which generate responses. Now, for applications that do not have complex business logic, aka all the applications we do in this class, we can usually skip the service layer and just do the simple logic in controllers. So now that we know the common architecture of a web MVC application, it's easy to understand these annotations. So controller is used to annotate controllers, service is used to annotate service classes, and the repository is used to annotate repository classes. For everything else, we can use either component or bin. The difference is that component is a class level annotation like controller, service, and repository. In other words, it's an annotation put in front of a class. And a component annotation basically tells a framework to create a bin object from that annotated class. A bin, on the other hand, is a method level annotation. It basically tells a framework to create a bin by calling that method. In other words, that method would be a so-called factory method used to create bins, and this annotation will be used to annotate that method. Okay, now that we know how to create bins, let's change the guestbook example so that we keep the list of guestbook entries in a bin. As shown in this diagram, this allows us to inject the guestbook entries to any controller or to any bin for that matter. So this is the example we did last time, and I want to create a new project for guestbook because later on I want to use to demonstrate some Spring MVC features. So let's quickly create a new project. We'll do new project, and it's a Spring Starter project, and the name I'll call it guestbook, and the Maven jar Java 17 group artifact guestbook, and I'll call it guestbook example using Spring Boot, and the top level package CS3220, which is fine, and we are going to use the same three dependencies, free marker, DevTools, and Spring Web. And let's create it. Okay, so now we have this empty empty project, and so what we want to do is to create a bin that holds a list of guestbook entries, and since it's not a controller or a service or a repository, we can use either component or a bin. Component, we have to use it on a class, and a list of guestbook is not a class by itself, but we can wrap it inside a class. So we can do something like this. I'll create a new class, and I'll call it data storage, or just call it data store. And inside data store, we'll keep a list of, actually, let me see if I can just copy over some code from last time. So we'll keep a list of guestbook entries. Before we do that, we need to copy over the class first. So I'm going to put it under the model package as usual. And let me copy over, where is copy? Copy here, and let me put it in this package, where is paste here. Okay, so this is our guestbook entry, name, message, date, auto, create ID. Let's get rid of subproperty all. What else do we have? So everything else looks fine. So this is our guestbook entry class, and now inside data store, we are going to keep a list of guestbook entries, and inside the constructor, we're going to create a list, and we're going to create a couple of entries, and getters and setters, of course. Okay, now we have this class, and to make this thing a bin, we are going to add the component annotation to it. And so that's the first way to create a bin that holds a list of entries. We create a class and we make it a component. What about the other way to create a bin using this bin annotation method? Well, to do that, we need to still create a class. And we need to annotate that class using this configuration annotation. So let's do it like that. So the name of the class doesn't matter. Like in pretty much everything in Spring, is all depends on the annotation rather than class name. We can name this thing anything, this class anything, and similarly we can create a class with any name, then add the configuration annotation to it. So this one I'm going to call it data config, and I'm going to give the configuration annotation to it. So you can think of this class as basically a configuration file that is written in Java, basically. So in the good old days, Spring actually uses XML file for configurations, but the modern iteration all uses Java code as configurations. In this particular case, we're creating a class and it serves the purpose of a configuration file, basically. And inside this, then we can create a method that returns a list of entries, and the return value will be made into a bin with the bin annotation. So we'll say guest book entry, and we'll call this method entries because the name actually is kind of important. Okay, and inside here we'll do pretty much the same thing. And we'll say list of guest book entry, and then we return entries. Okay, so this is a method that returns a list of guestbook entries, and we can make it into a bin by adding the bin annotation, and so this is basically the second way to create a bin. So this one basically says we can remove public from this method. Okay, so let's do that. Then okay, so just to distinguish between the bin created from here and the bin created from here, let's change it a little bit. We'll say Tom says hi from component bin, and this one Tom says hi from bin or at bin, annotation bin, and this one says annotation component. Okay, so later on we'll see which one gets injected. All right, and so now we have these two bins, and let's quickly create the controller class, and we will create a package called controller, and do I want to copy over this controller? Let's create a new one. So we'll create a class. Class, and what do I want to call it? Call it main controller, since we probably only need one controller for this application. So I'll just call it main controller, and it is a controller, of course, so don't forget the annotation. And inside, I'm going to create the index method and map it to the root path. This index method will need to pass a model to the view, So we could say which one do we need? The spring one. And I'll say here private. Which one do we want to inject first? Let's inject data store first. So we have a private data store, and uh, later I will say model add attribute, entries, and data store and entries, and then we return the view. Okay, so that gives us a controller, and then we need what do we need? We need a view. So we need a view, and can I copy over? Does this one have? I think this one, yeah, this one has the guestbook table. So let's copy it over and put it here. And this one, let's get rid of first name, last name, and this one I'll say it's a guest book, and say guest book, and this one is free marker list directive. Go through entries, name, message, date, entry name, format. Okay, I think we'll also need the, since we are using local, what's that thing called, local date, we'll need this configuration plus the additional dependency. So let's put this configuration in there. And let's put where the other one? So the actual dependency for handling local date, and let's put it in here. Okay, so I think this should be it for our new. Which one is not saved? Is this one not saved? Okay, so this is our new guestbook application, and let's run it. Oh, not run server. So it's run as Java application. And open up browser, go to localhost. And there's an error here. And so it says null pointer exception. And because this data store is null, which is what it should be, because we didn't instantiate data store, and of course it's null. So what that means is, although we have created some bins, we are not doing the injection yet. So we have created the bin that holds a list of guestbook entries, and the next step is to inject it into the controller. So how do we do the injection thing? Well, there are actually three ways. We can inject it directly to a field, like this one, or we can inject it via a constructor, or we can inject it via a setter. The field injection part is a little bit confusing because there are actually three annotations that do pretty much the same thing. The first one, auto-wired, is a Spring annotation, and then there are two more that are defined in Java EE specifications. All three are supported in Spring, and like I said, all of them do pretty much the same thing. So um, we can just pick anyone to use. My pick is auto-wired because I'm more familiar with it, and also I'm not worried about doing any Java EE application without using Spring, because that would be not very good. So I'm comfortable using this, and if you prefer using the other two, that's perfectly fine. They ultimately do the same thing. Now, this is the first way of injecting directly to a field. We'll see in a moment how to do it. Then the second way is to inject via constructor. This is considered the best practice, but it's a little bit more verbose than field injection. We'll see why in a moment when we look at the example. The last one is setter injection. It's basically like constructor injection, but instead of using a constructor, we use a setter. In my opinion, there's no reason to use setter injection because constructor injection is objectively better in almost all situations. So knowing this, let's do the injection thing. We already have this field, so naturally let's try the field injection. So just put auto wired on this field, and then it should work. And if we refresh here, it indeed works, and it says hi from component. Yeah, this one just need to be refreshed a couple of times. So as you can see, it's actually quite nice. This is a field injection, and if we want, we can also field inject the other one. So let's say instead of injecting the data store bin, we inject this one called entries. Now, this one is a list of guestbook entries. It's not a class by itself. So here we simply say list of guestbook entry and entries. And this should get this bin here. And now, because it's already a list of guestbook entries, we can simply say entries here. Okay, so is there an actual parenthesis? Yes. Okay, so notice here that it says hi from component annotation, meaning that we are getting getting this one. So now we should get this one that sets high from bin. And if we refresh, it indeed sets high from bin. That means now when we do auto wired on this one, it indeed works. So this is two examples of using field injection, and let's change this to using constructor injection. So let's say instead of saying auto wired here, we simply create a constructor of main controller, and this constructor, let's say, do we want the data store one or data config one? Let's say we want the data config one. So the data config one will give us a list of book entries, and here we say this entries as entries. Yeah. And now if we refresh here, it still works, meaning that the constructor injection is working. So going back to here, we can see that constructor injection is a little bit more verbose than field injection. If we do field injection, we can just put auto wire here, and we don't need to write all this. However, these days, constructor injection is considered the best practice for a few reasons. One is that if we look at this code actually works without framework, right? Because entries indeed gets initialized by this argument to constructor. Now, previously, there's no this one, and without a framework, we can see that this one never gets instantiated. So from a coding perspective, this one is more natural. There are a few additional benefits, like this one ensures that all the dependencies are there when the object is created, even though it's a little bit verbose, but it also serves as an indicator that if your class has too many dependencies, maybe you are doing something wrong. If you write lots of dependencies in the constructor, it's an indication that you probably need to redesign your class a little bit. And also with this, you can declare this field as a final field, so that this reference doesn't get incidentally changed. All in all, this constructor injection is considered the best practice. But if you prefer field injection, I can stand. And I personally also use field injection quite a bit when there are more than a couple of dependencies. Setter injection, what that means is that you would have a setter, something like set entries, and you would put auto wired here, and inside you would say it's not entries, it's entries passed from here. List, yes, entries, something like that. So as you can see, the setter injection is pretty much like the constructor injection, but I much more prefer constructor injection because you would have all your dependencies in one place instead of in multiple setters. If there are many setters and getters in your class, you have to scroll up and down just to find which ones gets injected. And also um, there's a benefit that having all the dependencies set when the object is created and so on. So all in all, there's almost it's there's it's kind of other than some very special cases where certain dependencies are not required, certain dependencies are required, and so on. Except for those rare cases, constructor injection is always better than setter injection. So this one you can kind of ignore. Generally speaking, use constructor injection, um, and unless you want to save some typing and then use field injection. But by and large, use constructor injection when possible. Okay, so that's how it can get injected into controller. Then let's quickly understand how this thing works. So what happens is this: first, when the application starts, the framework will create bins based on annotations, right? And so in our example, it will create 1, 2, 3. It will create 3 bins, right? It will create a bin called main controller, and that's because this bin has this controller annotation, and it will also create a bin data store because this bin has this component annotation. So it will create a data store bin, and it will create a third bin called entries. Notice that this one, the bin is on the method, right? So it will create a bin called entries, and this is this is the third bin. So how does the so-called wiring work? So in other words, how does the framework decide that entries should be injected into main controller, not the other one? The answer is that it does a number of things in sequence. It first tries to match by type, meaning that it will look at main controller, and it will see that main controller is looking for a dependency which is a list of guestbook entry type. And in this and among these 3 bins, only this entries bin is a list of guestbook entry type. The data store bin is of data store type, and this one is a list of guestbook entry type. And because main controller needs something that of this type, so this bin gets matched to main controller and gets injected, and that's why we are getting this. So in other words, what the framework does first, it tries to match bins and dependencies if their type match. Now here is another case where implementation would also match its interface type. Uh, so in our example, the type matches exactly, but let's say in the case of this example where we have an interface defined inside the controller guestbook service, then either guestbook DB service or guestbook mock service, if any of these two is a bin, then that will match this interface type because this class implement that interface. So that's what the framework does. First, it tries to uh, match by type, match a bin with an implementation by type. Now, what if, let's say, we have two bins that have the same type? So let's say in this config class, we have two bins, and the first bin is called entries, and the second bin is called entries2. And the first one will say hi from bin, and this one will say hi from bin number 2, for example. Okay, so if we do that, then which one gets injected here? Now, notice that match by type now is not going to be enough because we have two bins that have the same type. Now, if we look at it here, it still says hi from at bin. So that means this one still gets matched. I think I'm doing something. I need to save it. Okay, same thing. So it's still matched to entries. Now, however, if we change this to entries 2, and this one changed to entries 2, and if we refresh, we'll see that it says hi from at bin number 2. In other words, this one gets matched to the main controller or gets injected into main controller. So now you can kind of guess that when there are two bins with the same type, it tries to match the bin name. And that's indeed what happens. So if the framework finds more than one bin that has the required type, then the next step is it tries to do a match by qualifier. So qualifier is something similar but different from a bin name. And you can add a qualifier to a bin using the qualifier annotation. And later on, when you auto-var a dependency, you can specify the same qualifier using this annotation. We didn't actually use this qualifier annotation, so the framework actually didn't find the unique bin using qualifier. So what it does next is it tries to match by name, and this happens to be the name of the bin, and it tries to match that to the name of the dependency. And that's why if we say entries 2 here, we get this bin, and if we say entries, we would get this bin. So this is how auto-vary works. First, the framework tries to match by type, then by qualifier, and then by name. It's possible that after all this, it's possible that the framework couldn't find any bin that is a match, or it could it can still not decide which one of multiple bins should be a match. So in any case, if it cannot find a unique bin for a dependency, it will throw an exception, and then we'll need to change our code a little bit by either changing the name or adding a qualifier or something to make it work. So that's how auto-wearing works. And the last thing I want to talk about is the so-called bin scopes. There are two basic Spring Bean scopes, singleton and prototype. By default, bin is a singleton, so if we don't specify anything, all these bins are singleton bins. What that means is that there's only one copy of the bin for the whole application. So this is why when we create the bin that holds a list of guestbook entries, this bin can be shared by all the controllers in the application because there's only one single instance of this bin. It's a singleton bin. For the vast majority of the cases, we do want the bins to be singletons, but occasionally we want multiple instances of a bin. And in those cases, we can configure the bin to be a so-called prototype bin using the scope prototype annotation. So if, for example, we create this bin as a prototype bin, what that means is that what that means is that whenever we try to inject that bin into a controller, a new a new copy of that bin will be created. So if we inject this into controller one, the controller one will get a copy. And if we try to inject it into controller two will get its own copy. So if we specify the bin to be prototype bin, this will be what happened. Okay, so singleton and prototype scopes are available in all Spring applications, whether it's a web application or non-web application. Now, if an application is indeed a web application, then there are three additional scopes we can use: the application, session, and the request scope. We use these scopes quite often when we wrote servlet code, but in Spring applications, we almost never use them directly. Behind the scene, the framework still use scopes like session and request, but in our application code, we very, very rarely use them. Mainly, we just use singleton. Okay, so that's about it for dependency injection in Spring. Thank you and see you in the next video.